So far, Colin, we have talked about how many doors are in our house, and this is our data there, and how many windows are in our house, that's our data here. We're going to talk about stem and leaf plots, and then dot plots down here. And we're going to do doors for dot plots and windows for the stem and leaf plot. Pause if you need to. Okay, so for a stem and leaf plot, usually it looks like kind of like a T, and one side, this is the higher value side, and this is the lower value side. In this example, I'm going to put tens over here and ones over here. This helps you organize your data in a concrete way. So for windows, let's see, my lowest number is 16 and my highest number is 35. So I've got 10s, I've got 20s, and I've got 30s. So I only need 3 things here. Usually put them in order. You don't have to go from 0. If it was like, if there was somebody who had like 5 windows in their house, you put a 0 in that column. Or if there was somebody who had 75, you could put like dot, dot, dot and put a 7, like that. You can also have empty columns as well. So if I start going through this, let's see, I've got a 16. So that represents a 16. See, it's a 1 on the, or 6 on the one side and a 1 on the 10 side. 33 is down here. They do not need to be in order. I've got 35, 2 35s. Put commas in between so people know what you're talking about. 28, 21, 23, 31, 26. Now, people don't usually actually even write the word tens and ones on here. That's what this key is for. So you pick any number you have, like 28, like this, and you say that equals 28. And you have to have a key in a stem and leaf plot. You have to say on the side what it means. Because it could actually be something like, if I was talking about grade point averages, my left side could be like 1 point, 2 point, 3 point, 4 point, right? And so we could have 4.0s or 3.5 or 2.7 or whatever it is. You could also have like, here's one where they have number of text messages sent. And do you see how they say 15/5 means 155? So here they've got like a whole bunch of tens, but you could have like thousands on the left or something like that. Anything like that. But that's a stem and leaf plot. Pretty simple, pretty fast, actually. So this homework isn't going to be as horrible as you think it is. All right, dot plots. Now, a dot plot has like a number line at the bottom. Everybody's written down the doors, right? The door numbers from the top. You're not relying on me to show you? Good. It looks like the lowest one I have here for doors is 16, and my highest is 28. So I'm going to count by 2s. 16, 18, 20, 22, 24, 26, 28. Right. I obviously made that way too big. And I'm also going to put little lines here. I'm not going to mark them, but you know what they mean, right? Like halfway between 24 and 26 is 25. So a dot plot, you just stack dots on top of each other to show where things are happening the most. So I'm going to start with 16. I'll put a dot right there. And then 19. Make sure that that first row is all lined up. 24. 17. This helps you see the spread of data really easily, which is nice. 25, 27. You see how we got 2 15s? Oh, we had a 15. Whoops. Did somebody realize that and refuse to tell me? You stinkers. Nobody saw it? All right. So for the 15, you actually stack them on top of each other once they start repeating. There's a 28. There doesn't have to be a key for this. You just have to have your label at the top. Here's an example of one where things start bunching up a lot. Do you see how after a while you can really see where most of the people are? What do you call a data point that's way outside of the norm, way far from the others?
Outlier.
an outlier, okay? It lies outside of the norm. I had a kid ask me once in class, but how do you know if that person's lying? Like, this question is, how many text messages have you sent this month, right? Most people are here in the hundreds, 160, would probably be a lot more now these days. This book was published like 6 years ago. We had some weird outlier here who's at 78, and so a kid said to me, how do you know that they're lying, though, if they're an outlier? Being an outlier doesn't mean that you're lying about your data, doesn't mean that you're being, I mean, you could be, right? This person could be lying, but you don't have to be. It just means that the data lies outside of what the norm would be. So that's it. All right, so I'm going to start giving you the assignment. You can work on these 2 problems tonight. Page 63, number 17, and 23. No, let's do 24. That one's way more interesting. 23 is about systolic blood pressure, and 24 is about how long houseflies live. I think that's way more interesting, right? Like, who? I want to know. How long do you think houseflies live? Couple days? Apparently, anywhere between 4 and 14 days. Who knew? All right. I'll add to that assignment tomorrow, but that's it for today.